Example 3. Okay, this is, next page? Yeah. I'm going to teach you the infamous slope formula that you will be using for the rest of, well, I don't know the rest of this course, but definitely all throughout Chapter 7 you'll be using this formula. This is very important.
This looks hard.
Okay? I'm going to teach you the slope formula using an example. Okay? I want you to plot the following 2 points on the grid below. Negative 3, 6 and 5, 2. Let's just plot those points really quick.
Oh, whoa.
Okay? Negative 3, 6 and 5, 2. So negative 3, 6 goes here. You can use a bigger dot than that. Negative 3, 6. And 5, 2 is there. Am I right? Mm-hmm. Alright. And we're going to label one of those dots A. And the other dot B. Oops. And we're going to find the slope made by connecting those two lines. Okay, so I'm going to connect them together. That's a little better. Alright. How do I find the slope of that line? Let me ask you before we try to do that. What kind of slope is this? Negative. Okay, good. Carl is going down, left to right. Right? But how would I find the slope? Well, like I mentioned before, slope, as you know, is rise over run. The rise is how much vertical distance I either gained or lost. And the run is how much horizontal distance I either gained or lost. So what vertical change took place between A and B?
4.
4. How do you know that? Which coordinate corresponds to my vertical height? X or Y? Y. So Y went from 6 to 2. I went down 4 units, right? Or you can just make, one other way of doing this is making a right triangle between those 2 points. Okay, and the height of that triangle is how much? 4, right? This is 1, 2, 3, 4. And the run of that triangle, or the base of that triangle, is 1, 2, 3, 4, 5, 6, 7, 8. Which makes sense because you go from negative 3 for x to 5 for x. That's a difference of 8. Okay, so my rise is 4, my run is 8. Okay, so rise over run is 4 over 8. Okay, maybe I should say I went 4 down, so this should be negative 4. Maybe that's an important clarification. And 8 to the right, so that would be 8 positive. Reducing it, I get what?
Negative 1 over 2.
Negative 1/2. Okay, that's a lot of drawing to do, right? You got to draw the triangle and count the squares. That's a lot of drawing, right? There's a faster way we can do this. Remember how I said before that the rise is the difference between the y values and the run is the difference between the x values? Okay, we can use that idea to create a formula that will work for any pair of points. Okay, it's known as the slope formula, and it looks like this. Okay, to find the difference between the y values, I take one y value, let's call it y2, and I subtract the other y value, y1. To find the difference in the x values, I take one x value, x2, and I subtract the other x value, x1. You know this? Well, good. Okay.
Alright.
So let's look at the 2 points I had. I had negative 3, 6 and 5, 2. It's up to me which of those points I want to call x1, y1, and x2, y2. It's up to me. Okay, it doesn't really matter. Let's just call this one x1 and this one y1. And we'll call the other guy here x2 and y2. Okay, and we're going to use the slope formula to find the slope based on those values. Remember, all we're doing is we're finding the difference in the y values and comparing it to the difference in the x values. With me? Alright, so let's do it. We're going to go y2, which is 2, minus y1, which is 6. That's the difference in the y values, divided by x2, which is 5, and negative 3, which is x1. Notice I'm minusing negative 3 on the bottom. Okay, be careful there. So the numerator becomes what? 2 minus 6 is negative 4. 5 minus negative 3?
Positive 8.
Negative 8.
Positive 8. That's the same thing as saying 5 plus 8. And you'll notice this already looks similar to what we had before. So that simplifies down to negative 1/2, just like we had before. Now to prove to you it doesn't matter which one you call x1, y1, and x2, y2, I'll just show you, I'll change these around. So now I'll make this one x2, y2, and x1, y1. And just really quickly, m equals y2 minus y1, so 6 minus 2. x2 minus x1, negative 3 minus 5. 6 minus 2 is 4. Negative 3 minus 5 is negative 8. That still reduces to negative 1/2. Okay? So it doesn't matter. Your mistake will come in, however, if you go 6 minus 2, y2 minus y1, and then 5 minus negative 3. That will give you a mistake. Okay? So it doesn't matter which one you call x1, y1, or x2, y2. Just make sure that if you subtract this one from this one, you also do the same with the other pair of coordinates.